So I want to go over question 5 from 2011 from that exam. These are all supposed to be easy questions. I mean, when you are into the box proof, you will find that these questions should pose hardly any challenge. It's more sort of testing you that you know the techniques and the general strategies for how to do box proof. So there will be no challenge here really, but let me do each of them in turn. So in this first question, we can solve that by just using the same rule over and over again. So it's an implication, so the first step should be obvious. We must justify this conclusion by an implication introduction. And again, we have to justify this line here, line 2. Again, we must have done it by an implication introduction. And so forth. The same, it must have been an implication introduction. And this must have been an implication introduction. So we end up with the solution here. This is a box proof. The only step, so to speak, that could have gone wrong is here when we have done all these implications, we have to justify line 5. And we could, if for example we had an E in this place or some other letter F or something like that, then we could not have justified it, and the proof could basically not have been done. But in this case, we can justify line 5 because you can see we're inside a box where we already assumed A. Here, so inside this big box we assumed A. So of course line 5 can simply be justified by referring to that fact. So that's why we do that here. So this is the kind of thing you learned after 10 minutes. Actually, when we did box proof, you remember I was always impressed with students after 10 minutes can do these things and annotate them correctly. So that you did in class. But so this you should be able to do. It doesn't take long to learn to do this, but you can do a few other examples. So let's take another example here. So this one again, the first step should be obviously we do an implication introduction. And now it's just a matter of doing the AND game. Everything is about converting this formula, this AND, into this AND. So the first step is to break them down. Break all these ANDs down. We can, for example, do it like this. Maybe we take this one and eliminate this, and we can take this one. So this is the proof, you see. Actually, sorry, this is not the proof. This is now we took this formula and we broke it down into the basic building blocks A, B, and C. Now we have to put things together again, but we are kind of almost done. But we of course we can still not justify line 6 because we have to get this. So how do we do that? Yeah, like this. And now every line can be justified, you know. So so this is like if you want the model answer for the second question. I mean, it's almost only this way you can do it that makes sense. I mean, of course, technically speaking, you could have inserted some other nonsense line here in between that had nothing to do with the problem. It would still be a correct box proof. For example, if I wrote a, let's say, I could sort of have added D implies D, for example, somewhere, which is tautology, and I could have added that in here. I don't even know how to do that in Jape. Jape can kind of only do the sort of natural proof, but technically it would be correct to have a box here, for example, saying D in the beginning of the box, an assumption, then D here, and then D implies D, or something like that. You can, so to speak, insert any other box proof in here between, say, line 3 and 4, any other box proof, and then just ignore it after that. It will still be a correct box proof. I just mentioned that to okay, so this one, let's see, we have an implication here. So the first step should be to draw a box on top. We assume A and want to get to not A. And the next step is also automatic because we want to justify a not. The fact that there are two not you can kind of ignore. Just think about it like a not you want to justify. And the canonical or sort of natural way to do that is to draw a box on top and assume the thing without the not. So we had a not and something, so we take the thing without the not, and then we want to get a contradiction from that. In this case, you can see we can justify it because we have both A and not A inside this inner box. So here we have the proof. Every single line is now justified. Now this one is also pretty automatic. There's one tricky step which you should also know because we've discussed it many times. But we have these implications, so let's see. The first step should be obviously we do an implication introduction. So we draw a box on top and start off with this, and this is our target. We repeat and repeat. And this is a stage where we might get stuck because we have to justify C. But now we cannot just draw a box on top of the C or do anything like that. That doesn't work. So we have to justify C. And the key thing here is that, well, what you also can see, we not have somehow to use what we have up here available. You see, we see a C up here. So what would be nice to have if we could have A implies B at this stage. If you somehow could justify A implies B, then by combining that with line 1, we would have the C. And this is indeed the so Jabe cannot work it out 100%, so we probably have to do this forward. Now let's see if we can work it out. Yes, now Jabe could work it out. So, but the key thing is that we assume we do like a kind of wishful thinking. We say we want to show C, but wouldn't it be nice if we had A implies B at this stage, and we could combine it with line 1 and get our C. And now the rest should be automatic. So we just, here we have the full proof. Okay, the bottom line sort of split, so we can put it like this. Here's a full proof.